Welcome to Unit 2 on the changes in the Earth crust, including earthquakes and volcanoes and the formation of mountains. We're going to start by talking about what happens to cause these changes in the Earth's crust, or what happens after the changes are caused. Last unit we talked about the tectonic plates and how when they interact with each other, it occurs at one of three types of boundaries. The divergent boundaries, where the plates are dividing, the convergent boundaries, where the plates are colliding, and those transform boundaries, where the plates are sliding past each other. Now, any change in the shape of the Earth's crust is called deformation. So, anytime you have a bend, a break, a tilting, anything like that, it's called a deformation, and they are caused by stresses. And stresses is just a force on a rock. And there are three types of stresses. There are compression stresses, tension stresses, and shear stresses. And this deformation can happen any time the rock changes shape, changes volume, changes size in response to one of these three types of stresses. And all of this, keep in mind, is happening in the crust, which is part of the lithosphere, which is that outer layer of the Earth. The first type of stress is the compression stress. And the compression stress does what it says. It compresses rock. It squeezes rock together. Alright, we can see it down in the picture here. One force is pushing rock one way. On the other side of the rock, a force is pushing it the other way. And so what we've got happening is that rock is getting squeezed. And a lot of times we end up with this little bulge in the rock. Alright, it reduces the amount of space. Reduces that volume that the rock is taking up. So sometimes it pushes it up or moves it deeper down into the crust. And as you should hopefully have thought about already, this compression, this squeezing force happens where rocks get squeezed together, which is a convergent boundary, where you have two lithospheric plates pushing against each other. It's a squeezing action. The second type of stress is a tension stress. And this tension stress is the opposite of the compression. Alright, this is where the rock is being pulled away, kind of like taking a piece of Play-Doh or silly putty and stretching it away from each other from the center. And so the crust tends to start to get really, really thin as the forces pull it apart. And the rocks become thinner and thinner. And this is happening at the divergent boundaries, where the rocks are dividing because it's pulling those rocks away. So the rocks get stretched out almost like taking a piece of Play-Doh and just pulling each end of that piece of Play-Doh until it gets really, really thin in the middle. The final type of stress is the shear stress. The shear stress is a bending or twisting and maybe eventually a breaking of a rock. Alright, so you have two sides moving in opposite directions but not right at each other. So the rocks kind of bend, twist, and get pushed in opposite directions but not directly opposing, like not pulling away or pushing together, just like opposite directions past each other, and it leads to mostly a bending or a twisting of the rock. It's the hardest of the three to kind of visualize if you take a piece of paper and you grab each end, one end, and move one arm away from you and one arm toward you, you'll kind of see this bending, twisting that would happen in the paper. So this happens at transform boundaries where you have the rocks sliding past each other. Alright, and those are the three types of stresses: the compression, the tension, and the shear. Now, when a rock changes shape by the stress, we call that a strain. Alright, kind of like you can strain your muscles, the same type of thing. The rock can get strained. And if you apply the stress slowly over a long time, the rock might bounce back to its original shape. And this is something called elastic rebound, which you can kind of see if you slowly pull a rubber band apart, all right, and change its shape, and then you let go, the rubber band snaps back to place. A lot of energy can be released there. However, just like a rubber band, if you pull rocks too far, if you stress them too much, if the amount of stress is exceeded, we get a permanent change. And then the rock does not snap all the way back to what it originally looked like. There are two types of permanent strain. We're not really going to worry about the strain that's not permanent. There are two types. There's brittle, which means that the rock is going to crack and fracture and break. Alright, and then there is ductile strain, and ductile strain is no cracking, no fracturing. Alright, we still got a change in shape. This change in shape is still here, but there is that no cracking, no breaking of the rock. Whereas the brittle strains cause the rock to break. So brittle is breaking, ductile is not breaking. Now rocks themselves, the composition of those rocks is what can determine whether a rock will break or not break, whether it will be strained ductilely or brittly. And a lot of that has to do with what the rock is made of. Also the temperature and pressure of the rock. Pressure, high pressure, tends to lead to more brittle breaks because pressure is trying to squeeze things together, make it more solid. High temp or temperature usually leads to more ductile strains. And what we end up with is that at high temperatures, the rocks start to melt. They get more plasticky. Think of the asthenosphere. And you can have this ductile type of strain a little bit more. So at lower temperature and pressure, and I would even say lower temperature and high pressures, rocks will more likely deform in a brittle way. At higher temperatures, with low pressure, the rock's going to deform more ductile, because the higher the pressure, the more the rocks are getting packed together, and the lower the pressure, the less the rocks are getting pushed together. And as we'll find out in the next video of this series, or of this unit, we'll talk about the main types of ductile strain, which are called folds. When the rock folds, they didn't really bust out the creativity box for that vocab word. And then we'll talk about them when they break through this ductile strain, and we call those faults, which you've heard of before. Most of you will have heard of the San Andreas Fault in California. Well, that is a type of deformation. That is a brittle type of strain.